Hello everyone, this is the video for lesson 15A. It is the first part of modeling with linear functions, and today we will be using slope-intercept form and point-slope form and interpreting the slope. It's been a few months since you've used some of these formulas, so let's go ahead and go over a few of them. This one's pretty popular. This is your slope formula. You have to have 2 points on your coordinate plane to do the slope formula. Just make sure that you put your y in the numerator and your x's in the denominator. There are 2 formulas that you will be using. You'll be using the slope-intercept form because m is slope, b is your y-intercept, and then you will be using point-slope form, which is y minus y sub 1 equals m times x minus x sub 1. And the point, your coordinate, will be x1, y1, and your slope is m. All right, let's take a look at our first example. It says the graph shows the distance asteroid 2019 GC6, that's its name, travels in x seconds, okay? So whenever you look at a graph, there's things that you need to notice. First of all, you can see that that's a straight line, so it's going to be linear. Second of all, your x is in seconds and your y is in miles, and that's going to be very important pretty soon. Something that you're going to need to do immediately is make a little note that you have a point at 621. Now, if you only have 1 point, then you need to pick another. So for you to be able to write a linear equation, you have to have 2 points on the line. So you need to find another point on this line that's really easy to label. And the easiest one to label is right here at the origin. That is 0.00. Sometimes it's easy, sometimes it's not. All right, so right now we have 2 different coordinates. I'm going to go over here and I'm going to write down both coordinates because the first thing we want to do is we want to find the slope. So to do that, I'm going to write down 0, 0, and 6, 21. Those are our 2 points. Now this is the x coordinate, that's the y coordinate. Now remember, our slope formula is y2 minus y1 over x2 minus x1. I'm telling you right now, it does not matter which one you start with. So we're going to go ahead and let the top one be the 1s, and this one right here is going to be the 2s. So the way I'm going to set it up, I'll say 21 minus 0. So 21 minus 0 divided by 6 minus 0. So y is on the top, x is on the bottom, 21 over 6. Go ahead and simplify that. Use your calculator to divide. That is 3.5. Now this is the slope. It's really, really important. We're going to interpret that in a minute. So before we interpret, we're going to write an actual equation, and to do that, I'm going to write down our slope-intercept form, y equals mx plus b, and I'm going to substitute 2 things. I'm going to substitute the slope, and I'm going to substitute, let me highlight it, slope, and I'm going to substitute the 1. So you've got 2 points. I'm going to substitute one of those 2 points. It doesn't matter which one. So I'm going to write it down one more time. I have m equals 3.5, that's your slope. And then I'm going to use 0, 0. You can use 621, it does not matter. That is your x and that is your y. We're going to substitute everything except for b. So we have 0 equals 3.5 times 0 plus b, and just simplify and solve for b. Well, all of that is still 0. All right, so I have 2 very important pieces of information for slope-intercept form. I have my slope and I have my intercept. So I'm going to go to step 3. I'm going to write slope-intercept one more time. And I'm going to substitute the slope, which is 3.5. And I'm going to substitute the intercept, which is 0. Now this intercept right here is where your line hits the y-axis. And it should match. So it hits at 0. And I'm going to simplify that to 3.5x. So that is your final answer on that one. Now, I need you to pay a lot of attention to interpreting the slope. A lot of people want to ignore this part because it kind of makes them uncomfortable because they've never had to do it before. But we're going to kind of set it up in the same way. And it's going to help you just kind of like mindlessly write it down and then just think about it once you write it down. So what you're going to do is you're going to make a little box here, and that is the slope number. Okay, then you're going to make another box, and that's going to be your y unit. Now remember, your slope is the change in y over the change in x. So it's going to be the y unit per, same thing, x unit. Okay, so this is from your slope formula. Let's look at that again. Your slope formula is right here. So you're going to take this unit right here, and when you divide, that means per, and then x unit. So if you forget what order to put it in, just think change in y over the change in x. So let's plug this in. So our slope was actually 3.5. So I'm going to put in the slope number, hold up, 3.5. It doesn't really mean anything yet until I put the units in there. So the y units, if you look at your graph, it's in miles. So I'm going to go over here and I'm going to say miles per, and look at your x-axis, and your unit would be seconds. Okay, so does this make sense? It's going to be 3.5 miles per second. That's how fast that asteroid travels. So I think that makes sense. So if you want to write it in words, you're just going to say the asteroid travels 3.5 miles per second. And I'm telling you, the most important part of this is the fact that you've got your slope here, but then it's the change in y per change in x. Make sure you get the units in order. So the next part is asking you to actually apply what you learned from your equation. So let's write our equation down. It was y equals 3.5x. Now, if equations confuse you, what you can do is you can write words above the x and the y. So if you look at your graph one more time, the x-axis is in seconds. Oh, I just wrote it on the wrong one. So the x is seconds, and the y is in miles. All right, let's see what it wants us to do. It says the asteroid came within 136,000 miles. About how long does it take for the asteroid to travel that distance? So it's asking us how long. So we're trying to figure out seconds, but we know how many miles it is. So what I'm going to do is I'm going to replace y with the miles that they gave me. So it's 136,000 miles is 3.5x. So solve for x, because that's going to give us our time. So x is going to be equal to, we're going to round it to the nearest whole number. So 10,286 seconds. So I'm going to be super proud of you if you get this at this point, but this question specifically asks you in hours, okay? So what we're going to do is we're going to set it up to convert it. And when we convert something, we're going to use our T-chart. And I'm going to use S for seconds. Now, if you don't want your answer to be in seconds, then you have to put S down here. So seconds to hours, sometimes people know it, sometimes people don't. I'm going to assume you don't know it. I'm going to say that we have 60 seconds for every 1 minute. All right, so seconds is going to convert into minutes. Now, I don't want seconds anymore, so I'm going to mark it out. And I have minutes, but I need to change minutes to hours. So I'm going to put minutes down here and hours at the top, and then you need to fill in the numbers. So we all know that we have 60 minutes in 1 hour. So now that minutes are canceled out, I'm going to get my final answer. Make sure that you multiply everything on top and everything on the bottom. So we're going to type that in our calculator. Make sure you put parentheses around 60 times 60. So you get the right answer, and that's going to be about 3, oh, hold on, I can't see it. It's going to be about 3 hours. And that is an estimate. So So this question is very, very similar to example number 1. So if you're feeling really confident, stop the video and go ahead and follow step 1, step 2, step 3, and let's see if you get it right. But if not, just continue to watch and take notes. All right, so what we're going to do is start with finding the slope. And for us to find the slope, I need 2 points. And it's got 2 points labeled over here for us. Okay, remember this is our y's and this is our x's. So y's 18 and 15, x's 0 and 10. So 18 minus 15, 0 minus 10. So that's going to wind up being 3 over negative 10, which turns out to be negative 0.3. Okay, second thing we're going to do, I'm going to change colors. We are going to find the y-intercept, which is b. For us to be able to find b, we have to plug in one of these points. I'm going to just choose 0 and 18. It does not matter. So that's our x, that's our y, and our slope is negative 0.3. Take those 3 things, plug it in over here. Okay, so you notice that your slope is times 0. That's going to be 18 equals 0 plus b, and you wind up with b. Okay, now if you can just look at the graph, you can see that your y-intercept is 18. So this technique right here is very handy, perhaps if you have a table and you don't have a graph. So you can use this technique for everything. All right, last step, we are going to change colors, and I'm going to replace the slope and the intercept. So the slope is negative 0.3 and the intercept is 18. So that is our equation. Now we need to interpret the slope. So this one's a little bit more complicated. So let me change colors again. So we're going to start out with our slope, which is negative 0.3. Our y unit is thousands of dollars. And then we have to say per whatever our x is, number of payments. So we're just going to say payment. So obviously with it being negative, we are going to drop money. This is a car loan. So if you make a payment, you're going to owe less money. So that makes sense. This is kind of where you're not thinking about it very much. But if you really want to think about it, what is 0.3 thousandths? Just on your calculator, do 0.3 times 1,000. You wind up with 300. So it makes more sense if you say negative $300 per payment. So every time you make a payment, you are losing $300 on your car loan. All right, so this last example is a lot of the same thing that we've been doing. You're going to start out with point slope form, but you're still going to wind up with slope intercept form, just in case. First thing you want to do is determine, well, this is linear, it's a straight line. We're going to find another very convenient point, which happens to be at 0, 0. So I'm going to write down our 2 points, 0, 0, and 7. 24.5, and I'm going to use that to find the slope. So I'm going to do my y's and then my x's. Does not matter what order you go in as long as you are consistent, and that actually winds up being 3.5. All right, next up, we are going to plug this into this form right here. I don't care which one you want to use, but you need to pick one. I'm going to go ahead and use this one because it's so much easier to use than anything other than 0. So I'm going to write down m equals 3.5, and then I'm going to use 0, 0. That is your x and your y. Plug it in right underneath. So this will be y minus y1 is 0. M is 3.5, and then it'll be x minus 0. So this is what it will look like in point slope form. If you want to convert it to slope intercept form, you are going to solve for y. And those zeros are going to make this very easy. So that's just y, and then x minus 0 is x. So that looks a lot like something that was on the first page. It just happens to be a coincidence, though. Since this one is so similar to example number 1, you can go ahead and pause the video, and I want you to fill in the parts when you're interpreting the slope and see if you interpret it correctly. So just pause the video right now, and let's see if you can do it all on your own. All right, so what you want to do is you're going to start with the numerical value of your slope, which is 3.5, and then we have to use your y unit and compare that to your x unit. So this is going to be miles per hour. So 3.5 miles per hour. So it just says your friends hike, so on average, they're going to walk about 3.5 miles per hour, and that makes sense. So let's talk about the last part, the application part of it. It says your friend's scheduled checkpoint is 11 miles away from her current location. How long is it going to take for your friend to hike that distance? Okay, let's do the last time. We're going to write down our equation, and then above it, we're going to write down what each stands for. So y is in miles, but this time x is in hours because we changed situations. So it says, how long is it going to take for this person to walk 11 miles? Well, we're going to put 11 where miles is. And then we're going to solve for x because x tells us how many hours. And once again, it's about 3.1. We're going to round it to the nearest hour. So we're just going to say about 3 hours. Okay. And that's it for your examples. If you turn it over on the front and look at the top right hand, this is what you need to do for lesson, that should say lesson 1.5, and it'll be page 36. You've got 5 questions if you're in regular Algebra 2, and you've got 3 additional ones if you were in honors. And y'all have a great rest of the day.